All right, so now this one we want to do all kinds of stuff with. It says this is the original function. Notice this is an x squared. It's been moved to the left 1, turned upside down, stretched a little because of that 2, and then plus 5 means we moved the whole thing up 5. Now what they want me to do is to take that one and mess with it. They want me to move it 1 unit left and 4 units up. So that's in addition to what's already been done to it. Okay, so in addition to what's already been done, oh, and we actually are graphing this one, right? Okay, so let's see what's going to happen when we do that. So what I would suggest, why don't we make a little chart? I don't know if this is going to be what I want it to be. So f of x. Actually, let's do one more. So what I'm going to do, there's 2 things we're going to do to it. We're going to go 1 unit left. So we're going to go left 1, and then we're going to go up 4, and then here's what the new one will have on it. So I guess I don't really need that last column. So because this will give me, when I'm done, the left 1 and the up 4, I'll have the final. So let's just look at a couple points on the original one. So notice if we look at this original, this was x squared. It was moved to the left 1. It was turned upside down, and it was moved up 5. So if you look in the graph, you have the point -1, 5. So if I move that left 1, then that's going to be -2, 5, because you see this is going to be -1 from the x's. This one is going to be +4 to the y's. So I moved it left 1. Now let's move it up 4. And there's my new point. So I have a new point at -2, 9. Let's see what other points we're going to need to graph it. If that's the only one, then we could just go ahead and do it. Here, let's go ahead and find 2 more just for the heck of it. So I just did this point here. Let's look at that one because it looks like it's right on the line. So that's -2, 3. Let's move it left 1 and then up 4. So that would be the new point, -3, 7. And now let's take that symmetric one, the 0, 3, and let's move it left 1 and then up 4. Oops, I can't add, can I? Up 4. All right, so now we've got a few good new points to look at. And we could actually have kind of done this in the graph. If we take a point that's in the graph and move it left 1, up 4, 1, left 1, 1, 2, 3, 4. So there's my new point. Move this one left 1, 1, 2, 3, 4. Left 1, 1, 2, 3, 4. So we can kind of get an idea of what the new graph's going to look like. It'll look like that. So let's see what we actually need to graph this one. I haven't graphed a parabola yet with MyOpenMath. Uh-oh. Didn't mean to do that. Okay. So I'm going to pick this, and it looks like if we pick out 2 points, we should be good. So let's do that -2, 9 point. And then we can do either the -1, 7. How about if we do that one? So I just did 2 of the points I came across. I guess you only need 2 points, and we should be good. Oh, and they want to know what is the new coordinates for that turning point. Well, that was that first one we found. That was the -2, 9. Oh, and what is the entire equation? I didn't write down the original. It was -2. Originally, it was x plus 1, but we've moved it an additional. So now it's at x plus 2. So it was x plus 1, but remember we added 1 to the x values because we moved it to the left, which means in the equation we add 1, and that was squared. And then it had a plus 5 on it. Oh, I guess I can scroll up, can I? All right, so this is what it looked like originally. So moving left 1 actually adds a 1 into the equation. So now it's x plus 2. And then it was 5 units up. We moved it an additional 4, so now it's 9 units up, so plus 9.